Good morning, everybody. Yes, thank you for the introduction there. My name's James Dunlop. I'm a senior engineer with the Carbon Trust. And just to give you some background on myself, I'm an electrical engineer by background, a chartered engineer. And over the past 15 years or so, I've been involved in working on low energy lighting projects in various forms. So today's presentation is a technical webinar on low energy lighting. It's one of a series of 4 webinars as part of the Carbon Trust's Green Business Fund support for SMEs. There are 3 other presentations available. 2 of them have already taken place, one on heating, ventilation and air conditioning, one on motors and drives, and there's one still to come on compressed air, which is available on the 28th of March. The ones that are already taking place, they are recorded and are available for download online. So in terms of today's presentation, I'll just give you an overview as to what we're going to cover. As Penny says, the main presentation will last 40 to 45 minutes, and there'll be an opportunity for questions then in a 15-minute session at the end. So firstly, in terms of an introduction, I'm just going to talk through some more information on the Carbon Trust and also the aims of the webinar today before going on to the importance of good lighting, looking at traditional light sources that are out there within businesses, and also looking at the benefits of moving across to low energy LED lighting. We'll also look at other considerations when upgrading your lighting, and also talk further on the various aspects of support available through the Green Business Fund. So in terms of the Carbon Trust, we're a not-for-profit organisation with a mission to accelerate the move to a sustainable low-carbon economy. We're independent experts on carbon reduction and resource efficiency, and as part of our not-for-profit setup, we invest any surpluses from our activity back into our overall mission. In terms of the services we offer, they can be broadly split into 3 areas. We provide advice to businesses, governments and the public sector on opportunities in a low carbon world. We also provide footprinting advice to help organisations and products measure and certify their environmental footprints. And we also provide technology support to help organisations deploy low carbon technology and solutions. In terms of today's webinar, we're aiming to provide an understanding of what constitutes good lighting. We're trying to help you evaluate the type of lighting that you have presently and the opportunities for moving to LED technology and the savings that will provide. We're also looking to help you understand the other benefits of switching to LED lighting, and also to provide more information on the Green Business Fund in general, how to identify opportunities on your site, both for lighting upgrades and for other energy efficiency measures, and also how to go about obtaining competitive prices from our accredited suppliers, and also some more information on the 30% non-refundable capital contribution that is available. So I suppose the key point to take away is that converting to LED technology typically reduces your lighting energy costs by 70%. So there's opportunities for all businesses to reduce their energy consumption through improving their lighting energy use and upgrading to LED lighting with improved controls. So this next chart here gives an overview of the level of lighting electricity use across a range of sectors. So all businesses are different, and you can see here at the top the likes of storage areas, warehousing, organisations like that. Lighting can constitute between 70 to 90% of the electricity use of those organisations, so it's a very high percentage user in those circumstances, and then it varies throughout a range of different industry types here in this chart. You can see here that offices, depending on the type of the office, depending on the level of other services, it can range there from 20 to 60% in those organisations. It's lower percentages in industrial and manufacturing organisations, but that is largely down to the fact that there's other more intensive processes typically taking place at these sites, but it still does mean that there are significant opportunities to upgrade lighting in those industries as well. So the first main section we're going to look at is the importance of good lighting, and I suppose how we define good lighting comes down to a range of factors. You can see here in this chart that it has an influence on many things. It has an influence on health and well-being, on the illumination levels, and also safety in your site, light colour as well, colour rendering. Glare can be an issue as well, so that's something that needs to be minimised. And of course, the main reason for the presentation today is to highlight the ways that cost, energy and carbon can be reduced through effective lighting. So firstly, in terms of the impact on well-being, light significantly influences people's activity and their sense of well-being. It has a positive impact on health and can even enhance or influence biological processes, and that's something that's highlighted by the chart here on the circadian rhythm. So I suppose we're complex creatures, and light has an impact on people's well-being as well as other factors. It also impacts on our ability to work accurately. You can see here in the chart we're looking at illuminance levels, which is really a definition of the amount of light by area. So as that light level increases in a space, you can see there that the relative errors for performance of certain tasks reduces to a certain point. Also, people's work rate can increase if they are in a better lit environment, again to a certain point, and having the correct level of illuminance from a lighting system is important. And in terms of what that correct level is, there's some guidance here from CIBSE. We can see there different areas require different levels of light. In offices and areas such as laboratories or retail environments, levels of around 500 lux are appropriate. In less frequently used areas such as corridors or entrance areas, lower levels of maybe 100 lux or 200 lux might be more appropriate. So that's important to note, and it's important not to overlight spaces, and to make sure that you have the appropriate level of light across your facilities. Light colour too is important. This is a measure of the appearance of the light. It ranges in practical terms from about 1800 Kelvin, Kelvin being the measure of the colour, and that would be a very warm amber light, through to 8000 Kelvin, which would be a very coolish blue light. So in most commercial applications, you'll be keen to see the colour range from around 2500 Kelvin, which would be described as a warm white, through to around 4500 Kelvin, which would be described as a cool white. So that would often be seen in applications that are maybe not well specified, that the light colour could be too blue or too white. So to avoid that, you would look to specify further down the light colour range there. And applications such as hotels or hospitality environments, levels of in and around 2500 Kelvin to 3000 Kelvin would be more appropriate. For office spaces, you might want to go slightly higher than that, and laboratories, factories, industrial spaces could go higher again, up towards the 4000 Kelvin range there. Color rendering too is important, and this really defines the effect of light on the color appearance of objects. You can see there on the slides the difference that the same object can take on based on different levels of color rendering. The image on the left at the bottom of the slide is taken in daylight with a color rendering figure of 100. The image on the right is taken there under sodium street lighting, which has a very low color rendering index, an index there of 5, and you can see that the scarf that's pictured has very different color appearance depending on the color rendering index that's applied. So it's another important factor again when specifying light replacement sources, and you want to move towards figures of up to 100, which is ideal lighting and is very comparative to daylighting. Glare is another issue that needs to be managed and is typically caused by excessive and uncontrolled brightness. So you'll want to have your lighting systems designed well to minimize glare. This is of particular importance in the office environment where you'll look to minimize glare to improve comfort of staff working in that environment. It's defined by European standards, and a unified glare rating is applied to evaluate glare. So we would often talk about UG 19 for office environments, and that would be a good level of glare control for the office environment. And of course, the main reason that we're here today is to talk about the minimization of energy consumption through improved lighting. And there's 3 factors there, really, as I would see it. The first would be improvements to the light source. So the level of power use of the light source can be significantly reduced by moving to LED lighting. Can be reduced by as much as 80% in many cases, and that's significant also when you're converting from sources that may already be considered as low energy, such as T5 lighting or compact fluorescent lighting. There you could see savings of up to 50% or within that region. So there's opportunities to move from most current light sources to LED and provide good savings. Secondly, presence detection. There's no point in lighting a space if there's nobody there. So the use of presence detection sensors will ensure that lighting's switched off when it's not required. It'll minimize the operating hours of your lighting system and again will maximize your savings. The third thing is daylight. Again, if you've good roof lights in place, if you've good light coming from windows, you can take advantage of free daylight, which is available through much of the working day often, and using daylight sensors, lighting can be switched off or dimmed just to maximize the benefit of that free natural light that's available. So generally what we would see would be opportunities to reduce lighting energy costs between 70 and 80% through recent projects we've supported through the Green Business Fund. And I'll just conclude this section with a case study. A company here, Blackout Limited, upgraded their lighting in 2 warehouses. The warehouses were running for relatively limited hours, 50 hours per week, but significant savings were seen. In this case, you can see here that by moving from metal halide and fluorescent sources, they were able to reduce their energy costs by around £9,000 a year, with a total project cost of £47,000. They're able to secure a capital contribution in this case of £6,800. That was at a time when we were offering just 15% in terms of the capital contribution. That's now moved up to 30%. And importantly, you can see there that their lighting savings were in around 76%. So it's the same sort of range as we're seeing typically through many of the Green Business Fund applications. Okay, so the next section that I'm going to come on to here is really about traditional light sources. You'll have many of these in your own facilities, and I'm just going to give some information on how to identify some of the common sources and the opportunities for saving by moving to LED from them. So in terms of a brief history of lighting, you can see here on this graphic when the various different lighting types came through. The likes of the standard incandescent light bulb will have come into being in the late 1800s. Fluorescent lighting has come in really into the 1920s. And that has moved on through the likes of compact fluorescent technology, which has come in the 1970s. And then towards the end of last century, LED lightings started to take off, initially used in electronics with the likes of red LEDs, and then moving through to commercial LED lamps that you can see here that were available from around 1998 onwards. And it's really within the past 10 years or so that we've seen LED lighting become the commercial lighting of choice, and is able to be used in all applications across businesses here in the UK and beyond. So in terms of existing light sources, the first example I have here is of an incandescent tungsten filament lamp. This is the standard type of lighting you may well have in your house or have had in your house before upgrading to better sources such as compact fluorescence or LED light sources. A key point to note here is really the figures at the bottom. There's more information on each of these slides, but I'll not go into it in detail. So in this case, the efficacy we're looking at here is around 5 to 20 lumens per watt, and that's important because that's really a measure of the efficiency or the output of the light. The lumen is really the amount of lighting that is emitted from a source, and the wattage is obviously the power use of it. So the higher that figure, the more light output you're getting for each watt. So if you note that through these slides, you can see here in this case this is particularly low at 5 to 20. Improvements have been made to filament bulbs, and the likes of tungsten halogen is still widely used in hospitality areas, retail areas, and display areas. You can see here it has a slightly improved efficacy of around 15 to 24 lumens per watt. And in terms of its other properties, it does provide good color rendering, as we've discussed. But you can see here that the lamp hours are particularly low for that type of technology. Fluorescent tubes provide better performance, as we can see here. There are different types in place at present. You would get T8 fluorescent, which would typically be the thicker type of tube. T5 would be slightly more efficient and would be the thinner type of tube that would be seen. They're used in many offices, commercial buildings, and in industrial spaces. And again, as we'll see later, by moving to LED, you can make significant improvements to the efficacy of these sources. Compact fluorescence came in really as an improvement to incandescent lighting, an original energy-saving lighting solution. They provide improved efficacy from the original filament sources that we discussed earlier, but again they can now be effectively replaced with LED technology to make further energy savings. High pressure sodium lights would be used typically in street lighting, also some industrial applications. As we saw in the previous graphic, they don't have great color rendering properties, as we can see here. Their efficacy is very good, so they are an efficient light source. Their lamp life is very good, but again, the performance of modern LEDs is now surpassing these. Metal halide lamps would be a similar type of lamp to the sodiums we looked at in the past slide. They're used again in many external applications, also in flood lighting internally and in retail spaces. They have better color rendering properties than the sodiums, and again, good efficacy levels. However, we would still be recommending that these two can be replaced cost effectively with LED. So another case study at this point, in this case it's for TOT shirts. They upgraded their metal halide and fluorescent lighting successfully. In this case they had operating hours of around 5,000 per year. They spent 36,400 on their project and were able to secure the maximum capital contribution of £10,000. So whilst we offer a 30% contribution, it is capped at a maximum of £10,000. In this case, they got very good savings, savings of 18,000 a year, and a project payback of in around 1.4 years. The lighting savings in this case were coming through at around 60%. So I'm just going to talk further now on the benefits of switching to LED lighting. This chart again looks at efficacy that we've discussed through the past slides and looks at some of the light sources we've discussed so far. So you can see here at the bottom the likes of incandescent lighting, which has very poor efficacy values in terms of their lumen per watt. Have improved slightly over the years, but only marginally over that period of time. Other sources mentioned there, the likes of fluorescent, have improved slightly over the course of time, but again have capped out at relatively low levels. The likes of high pressure sodium and metal halide too have improved efficacy figures, but other issues in terms of their color rendering and also their long startup time prevent them from being as good a solution as LED. And in terms of LED, the improvements have really come on in recent years, and in laboratory conditions we now see efficacy figures of 300 lumens per watt, and in practical commercial terms they're coming on towards 200 lumens per watt. So they're surpassing all of these existing sources that are out there at present. So as I say, LED lighting is rapidly becoming the light source of choice across all sectors and applications, and that's something we've seen here at the Carbon Trust over the past 10 years or so. Initially there would have been the perception that LED lighting could only be used in certain applications for the likes of hospitality environments or areas such as that, but improvements in the technology have meant that it can now be effectively specified and used everywhere. I would have seen industrial spaces that have been lit from heights of 25 meters successfully with LED sources, and in terms of its performance, it ticks all the boxes in terms of the color temperature that's available that can be specified to meet your requirements. The color rendering is typically good. The efficacy, as we've discussed, of the light sources is vastly superior to other lighting options out there, and it also provides very good lamp life in terms of its operation. So it'll typically last for 50,000 hours or more, which again surpasses other light sources out there. So I'm just going to take a look at some practical examples here of where LED lighting can be successfully used. In a warehouse or production industrial environment, you can see here a few different images of different lighting types. So the first on the left there is an example of 400 watt metal halide lighting. That'd be a typical light source that would be used in high level, as you can see there in the image. Again, it has a very long restrike time, so it has a long period of time to warm up. Isn't necessarily that easy to control. And in terms of running costs for each individual fitting, there will be a cost for running each individual metal halide fitting of around £385 a year, and that will be based on industrial use if you're operating that continually 365 days a year with a unit cost of 10 pence per unit. Alternatives to that would include T5 fluorescent fittings. These could be often used at high level, as we can see in the image there, with a total wattage of around 220 watts. In that case, the running cost would be in around £212 a year, a significant saving on the metal halide. But again, whenever we come to look then at the LED source, we can see there that the lighting can be effectively replaced with 150 watt LED, which again is a reduction in power of more than 50% from the metal halide, and that will give a running cost for each individual fitting of around £130 per year. So it's a big difference and a significant saving by moving across to LED technology in that case. And in an office environment, you would often see the type of lighting pictured here on the left. That's an older type fluorescent, T8 fluorescent with the thicker tubes there. In this case, we're looking at an example of a twin 58 watt luminaire. In an office environment, that might cost in around £50 for each luminaire to operate across a year. And in this case, we're talking about a year of office use, so running 5 days per week, 12 hours per day. The more modern type of fluorescent, T5 fluorescent, would typically have wattages of in around 49 watts, so a twin 49 watt fitting would cost in around £39 per year to run. And then contrast that with a more modern LED. Again, you're seeing a cost reduction of more than half there. And then the examples at the bottom look at the typical grid pack lighting that you would see in many offices. There would be a 2 foot square 600mm by 600mm lighting. The example on the left looks at an older type fitting that would have 4 18 watt T8 lamps in it. In that case, it would cost in around £32 a year to run each of those fittings. The T5, the improved, more efficient fluorescent, would operate at a significantly lower cost. We're looking at an example here with just 3 lamps in it, so it's 3 14 watt lamps, and that would cost in around £17 a year to run. And then the LED itself, LED panels would be available in this type of application, typically at around 30 watts or that sort of level, and that would cost around £11 a year to run. So those LED panels, again, would come in a range of wattages depending on your light output requirements, and that's something that you need to look at closely with a supplier to make sure you're getting the right levels of light when moving across to LED there. Just going to look at a further case study here. This is another company, Pentagon Plastics. They upgraded their factory lighting. We recommended daylight dimming in this case. There's an estimated cost for the project of £14,000 and a saving of £4,700. This was a recommendation from an energy assessment, which are available free of charge to SMEs and are provided under the Green Business Fund. So as well as making this recommendation for a £4,700 saving on lighting, there were other measures totalling £8,100 overall that were recommended within the report. And again, in this case, we were able to see lighting savings of around 60% in this case. So I suppose the case for moving to LED is strong in terms of the reduction in power, but there are other considerations. Some of those could include things we've discussed already in terms of control savings. You quite often see lighting solutions that are simply switched on and off with manual switching, but the use of presence detection, the likes of sensors in toilet areas can be effective, or corridors, or potentially in warehouse environments where you have infrequently accessed areas. They can provide significant savings by reducing lighting operation. The use of daylight dimming too, as we've discussed, will be beneficial to minimize use where there's good natural light. Other things simply like time control or last person out switches or photocell control for external lighting will be beneficial, again, just to make sure that lighting is not on when it's not required. And other things to consider if you are moving to new lighting solutions, it's worth looking at your wiring, the age of the wiring, is it in need of replacement, and these things can be tackled along with a lighting upgrade. Quite often it's most cost effective to replace lighting on a point for point basis, simply removing one fitting and replacing it with another more efficient one. But if you are looking at rewiring, it could be the case that you look at a revised lighting design and factor that into your plans as well. Also, it's worth looking to see if your current emergency lighting provision is adequate, if it's up to standard, and that can be brought in along with your lighting project as well. And also, are you planning to replace all your lighting across your facility? It may be the case that you have areas, maybe in production areas, that operate for long hours, other areas that aren't used so heavily. So do you want to take all of that lighting forward, or do you want to prioritize the areas with the highest usage? Okay, so I'll just give you some further information now at this stage on the Green Business Fund itself. The Green Business Fund is a scheme operated by the Carbon Trust to contribute to improve sustainability and energy efficiency. It's aimed at small to medium-sized businesses. It currently is running through to certainly the end of this year and early into 2018. The fund provides a range of services which I'll talk about in more detail in the coming slides, and I suppose the hope would be that there's aim to expand the scheme both in the UK and internationally should we get additional funding in the future. So in terms of who's eligible for the Green Business Fund, it applies currently in England, Scotland and Wales only. It's available, as I said, for small and medium-sized businesses. Also included within that are schools, sole traders and charities. And in terms of how we're defining an SME, we're essentially saying that it applies to businesses which meet any of the two of the criteria below. So no more than 250 employees, annual turnover not in excess of 25.9 million, or an annual balance sheet not in excess of 12.9 million. Another key point is that it doesn't apply to businesses which have more than 25% ownership by an entity which is not an SME as such. One of the key offerings we have is training. We're offering workshops across the country. You can see some dates coming up there in the coming month or two. There's also dates beyond those on our website, again around the country, up until the end of June presently. They're typically 2-hour workshops. They're hosted by a Carbon Trust partner, and they're giving additional support to help businesses understand energy consumption and to help them identify no and low cost measures. We're also providing opportunity assessments for companies with higher energy expenditure. We're providing that on site. For those with lower expenditure, we're providing that remotely. They're delivered by Carbon Trust engineers. We'll typically look to identify 3 costed energy saving recommendations, and often one of the key recommendations will be around lighting, and we'll also lay out next steps to help companies realize savings. Third strand of support that we provide is on implementation advice. We can provide up to 5 days consultancy support to help companies move projects forward from this recommendation stage through to implementation. You can see here in the case study on the right, we supported a community sports hall by providing design and specification advice for low energy lighting projects. We developed tender support in this case through the production of invitation to tender documents and specification documents. We also helped the organisation shortlist credible suppliers through our Green Business Directory and our panel of accredited suppliers, and then provided an independent review of the proposals at the end of the process. So in this case, this helped the company or the community sports hall move to LED lighting and to implement a project with a cost of around £8,000. And then beyond that implementation support, we also provide the capital contribution that I mentioned. So that non-refundable capital contribution is available to a value of 30% of project value. And that's subject to some terms and conditions, and essentially it applies to projects that have a payback period of 5 years or less. Where the project's payback is greater than 5 years, we'll typically apply then 30% to 5 times the annual savings. So we'll look at the saving in year 1, multiply that by 5, and then apply 30% of it. It's not so much a factor on lighting projects, but will be more so a factor in projects with longer paybacks, projects such as renewables or PV projects. So it's a straightforward process. We would need to see quotations, ideally from accredited suppliers. We will look at exceptions in some circumstances. We also carry out financial verification and identity checks as part of the process, and then there's a final technical assessment carried out by our engineers just to verify the cost levels and the savings associated with the project. So there's more information on this on the Carbon Trust website, and you'll find more information on how to apply there on the website. Another strand of support that we offer outside of the GBF is our interest-free energy efficiency loans. Now, importantly, these are available just in Wales and Northern Ireland only. They are funded through the local authorities in these areas, but will be beneficial to you if you are in those regions. They're designed to support businesses by, again, upgrading to more energy efficient equipment. Covers a range of technologies, as we can see there on the slide. In Wales, it's available for SMEs and is available for projects for funding between £3,000 and £200,000, so it can support large projects there. And again, the Wales, with having the overlap between the interest-free scheme and the GBF scheme, both funding supports can be used in parallel. So you would have the opportunity there to take up an interest-free loan and also secure a capital contribution from the GBF. For those of you in Northern Ireland, the interest-free loan scheme is available there, whilst the GBF is not. But in Northern Ireland, all businesses can avail of the interest-free loan scheme, and it's available here from £3,000 to £400,000. So the loan offer in this case is based on carbon savings, and we offer £1,000 for every 1.5 tonnes of CO2 saved. Again, there's more information on our website on that and on how to calculate the level of carbon savings associated with your project. And a third element of financial support comes through the energy technology list. Lighting equipment isn't explicitly listed on the energy technology list, but it is subject to a specification standard. So it's worth asking your suppliers if your lighting meets the energy technology list specification, and in that case there are tax benefits available through the use of energy technology listed equipment, and there's options for organisations that pay income or corporation tax to claim enhanced capital allowances or ECAs on the purchase of ETL equipment. So again, there's more information online on each of those three financial mechanisms of support: the GBF capital contribution, the interest-free loans, and the enhanced capital allowances. So that concludes the technical webinar on lighting, and it gives us an opportunity now for any questions that you might have.
So James, our first question comes from Christina Marshall, and it says, does the fund eligibility include retail businesses and landlords who manage business centres, industrial parks, etc.?
Yes, it would include retail businesses. In terms of landlords, I suppose landlords applying, if they have a responsibility for the energy use, if they are paying the energy bills, then it would certainly apply there. We have successfully awarded capital contributions to organisations that provide service to offices, places of that nature, and again, where they have the responsibility to pay the energy bill, then it would apply there.
Thank you, James. Our next question comes from Tom Vitch, and he's asking, are there any common myths about LEDs that you found in talking to companies?
Well, I suppose I think LED technology maybe had a bad press initially when it came out in terms of the colour appearance in particular of the lighting. So I think there would be myths around that in terms of the fact that people would associate it with poor color temperatures, but I think these days it's the case that you can specify the color temperature that you want and provide a warmer light through LED that you know, will be equivalent to other light sources. I think. Other than that, I think it's got to the point where really LED has gained so much traction that it is becoming the de facto choice for new lighting systems.
Right, so our next question comes from Kathleen McKee, and her question is there a minimum project value?
There is a minimum project value. The minimum project value for the Green Business Fund is £2,250, which will support at 30% a contribution of £750. So that's the minimum there. There are different minimum figures for the interest-free loan scheme.
We have another question here from John Kiffin Hughes, and he's asking, you mentioned that the Green Business Fund can support schools. Does this include access to funding, and how does a school fall into the category of an SME?
It is a bit of an anomaly there. I'm wondering, Penny, if one of the team there with you could answer that question.
Yeah. So schools are eligible. Like I mentioned, it is a bit of an anomaly in the sense that public sectors are not. But as long as initially it started out, as long as the schools are eligible for Salix finance, then they'd be eligible for the Green Business Fund scheme as well. But now it's a little bit simpler in the sense that as long as the school has their own bank account that they control, then they are eligible. So if we are then able to provide the 30% capital contribution directly to the school and not through a governing body such as the council.
All right, thank you, Sam, for that. Okay, so it doesn't seem like we've got any other questions. So with that being said, we've come to the end of today's webinar. So I just want to say thank you to James, and thank you to everyone for attending the webinar. If you do have any other questions, please feel free to visit the website, which is www.carbontrust.com/greenbusiness. Alternatively, you can contact us by emailing greenbusiness@carbontrust.com, or you can give us a call on 0207 832 4773. So on behalf of the Carbon Trust and our presenter, thank you for joining us today, and enjoy the rest of your day.